Hello, good morning everyone. I'm Adolfo M. Third from BSIT 3B, and today I'm going to present to you the final project for cryptography, which is a cipher app that contains different kind of ciphers, and this is the source code, and these are the ciphers. So I'm going to open the main so that you can see the whole application for the final project. So this is the final project, and it contains Caesar, Vigneer, Playfair, Vernam, OTP cipher, hashing, AES, DES. So now I'm going to proceed to Caesar cipher. So Caesar cipher is the most commonly used cipher, and it's not the best, but it's the most basic cipher that exists. So I'm going to put a message, and the key will be numbers. So for example is 1 2 3 4, or any number you want. So if you encrypt it, these are the results, and now let's try to decrypt it. So yes, and decrypt, so it matches, so the app is working correctly as intended. So now I'm going to proceed to veneer cipher. A short explanation for Vigneer cipher is it operates using a series of Caesar ciphers, each corresponding to a letter in a keyword. The keyword determines the shifting of the letters during encryption and decryption, introducing variability and making it more difficult to crack. So let's try this and put keywords that are only words, not numbers. So you see, this is the result, and let's try to decrypt it, and it matches. So it works. Now we can press reset or click exit, and now let's move on to Playfair cipher. Playfair cipher is a substitution cipher that operates on pairs of letters, digraphs, and it only works with keywords too, like the other ciphers. And let's try to decrypt it. Yes, and it works. It works. And now let's move on to Vernam cipher, also known as one-time pad, a systematic encryption technique developed by Gilbert Vernam in 1917. So, just like the other ciphers, the key is only keywords, but it needs to be the same length as the words or the plain text. So, yan. I used 4 letter of plain text and 4 keywords, and it worked. Let's try to decrypt it, and it matches. So just like that, it's simple and easy to use. The difference with OTP cipher lies in the randomness and secrecy of the key. If the key is truly random, used only once and kept secret, so it generates its own key, yes, and encrypt it, and it works. So let's try decrypting the results, and boom, yeah, it matches. So the only difference is it generates its own key with random to hashing. So hashing is not a cipher, rather it is cryptography technique used for generating fixed length unique representations of data. Yes, it has different results than other ciphers because it's not a cipher. And now let's move on to DES cipher. Has a block size of 64 bits and a key size of 56 bits. As a result, DES has been replaced by more secure algorithms such as Advanced Encryption Standard or AES. However, DES remains historically significant as pioneering symmetric encryption algorithm and has paved the way for further advancements in cryptography techniques. So it must be 16 letters to work, and those are the results. And let's check the decryption, and it matches. So just like that, now let's reset, and we're all done. That is all, everyone, and thank you for listening to my presentation. So it's, in conclusion, it's just easy to use, and it's not as complicated as you think, but it shows how different ciphers are made and how different it functions. And again, thank you for watching.